Cirrus Migrate Cloud is a patented solution created to help customers move data from anywhere to anywhere. This includes within on-premises data centers, between data centers, on-premises to clouds, between clouds, and between storage tiers or availability zones or regions of clouds with the least impact on production operations. In many cases, the migration and final cutover can be performed with zero downtime. Cirrus Migrate Cloud is block storage array agnostic, giving customers a single tool for all their block data migration requirements. This short video will demonstrate Cirrus Migrate Cloud migrating data from a fiber channel disk on-premises to a NetApp CVO ONTAP storage disk in the Azure cloud. For this migration, a CentOS Linux host is using block devices from an on-premises storage array. The goal is to migrate data from a disk on-premises to a NetApp CVO ONTAP disk in the Azure cloud without any downtime throughout the deployment, migration, and final cutover process, and with just a small amount of downtime needed to shut down the source application and bring it up at the destination without the need for any lengthy final synchronization. The migration is managed using Cirrus Data Solutions CMC portal in the cloud. We've already created a destination CentOS Linux VM, a NetApp connector, and a NetApp CVO in the Azure cloud that will be the target of the migration for the on-premises disks. The NetApp CVO for ONTAP is also ready. The source host is a CentOS Linux 7.9 server on-premises connected to a local fiber channel storage array. We can list all the cloud instances in Azure and see that the destination VM is listed together with the NetApp instances. We can now log in to both Linux hosts using the PuTTY terminals and prepare for the migration. The first migration step is to get the two hosts to register and appear in a project on the CMC portal. We can now prepare for the migration. Log into the CMC portal using your account. Here is the Cirrus Migrate Cloud portal. Cirrus Migrate Cloud is a data management as a service application that allows users to migrate and/or protect any block storage anywhere. Here's a list of all the projects you created or those you were invited to by other project administrators. To create a new project, click the Create New Project button. Enter a project name, a short description, and click Create Project. Click on the newly created project to open it. The project details and license information are here. On the left are items related to this project, such as hosts, migration sessions, integrations, and project settings. Here we see the name of the project, the owner, and basic information on the project. You can invite other users to help manage this project. Now let's see how we can discover these two Linux hosts. Click Hosts. There are no existing discovered hosts in the CMC portal yet. Click here to get the one-line curl installation command. We will install the agents on both hosts. Click the Linux tab and copy the command. Note that the command contains a project ID, which allows this command to be used by all the hosts that are supposed to be migrated with this project to register with this project. Here are the PuTTY terminals for both Linux hosts. Paste the copied command and run it. It takes about 30 seconds to a minute to do this. There is no user interaction necessary. As each host completes the deploy command and registers with the project of the CMC portal, they will appear in the host list of the project. The physical host on-premises is using CentOS Linux with a 16 gig fiber channel disk as the source. There's also the CentOS VM in the Azure cloud as the destination. The disk to be migrated is a 1 gigabyte disk on Dev DM1. To simulate a live workload, let's start a PostgreSQL database application and add new records to put some I/O on this disk. Here, the disk is now active with I/O. At the hosts window, we now see both hosts. The first step is now complete. The next three steps are to create the H2H connection, enter information for the CVO ONTAP, and create the migration session and auto-allocate destination storage using the integration plugin for NetApp CVO for ONTAP. We will now browse to the NetApp Azure Cloud Manager portal and see that there's an instance Azure CVO8 cloud environment hosting the Cloud Volume ONTAP that has no disk created yet. The requirement destination disks will be automatically created by the CMC plugin for CVO later. With the plugin, there is never a need to manually create destination disks or iSCSI clients at the CVO. Even the deployment of iSCSI drivers and multipath drivers at the host are automated by CMC. Let's create a host-to-host connection, or H2H connection in short, so that the source on-premises Linux host can send compressed and encrypted data to the destination Linux host, which will write to the NetApp CVO on tap. Click on the H2H connection on the left of the CMC portal and click Create New Connection to create the connection. Once connected, either side can send data to the other. We'll use the on-premises host agent as the source and the Azure VM host agent as the connection destination. Here, the destination address is the IP address of the VM in the Azure cloud. We can observe the source, destination, and destination VM IP address. Now that they're paired up, we can enable an integration to the NetApp CVO Cloud Volumes ONTAP in Azure by filling out the access credentials for NetApp CVO and selecting as deployment target the Azure VM for the purpose of verifying the connectivity for the integration. Here, the IP address is the IP of the NetApp Demo CVO server in the Azure cloud. Now we're going to create the migration session and start the migration by clicking on the New Migration Session button. We'll select the source on-premises hosts and the remote destination Azure Cloud VM. The entire list of all local physical drives is listed for the source host. Click and select the disk DM1, which has the mount point for the database, as the source, and click the Auto Allocate Destination Volumes button to automatically allocate the required disk in NetApp CVO. Since there is no destination volume yet, we'll use the auto allocation for NetApp CVO in Azure plugin to create the destination volume. Note that the plugin detected the need for installing and configuring the iSCSI driver as well as the multipath driver. We will migrate the source 1 gig Fiber Channel disk DM1 from on-premises to a NetApp CVO Cloud Volumes ONTAP in the Azure cloud. The destination disk is now being allocated in the NetApp CVO environment. This automated host remediation process will greatly reduce configuration errors and user learning curve for the preparation of any Azure host for access to the NetApp CVO disks, and it's consistent with NetApp's published best practices. We observe the new volume name with DM1 inherited from the on-premises volume. Now we're going to create the migration session and start the migration by clicking on the Continue button. The first step is to select the migration parameters, enter a short description of the migration, the periodic sync interval, and the impact level. IQOS is Cirrus Data's intelligent quality of service. It automatically throttles back the migration when the source volume becomes more active and opens it up when the source volume is less active. We can choose from minimum impact to relentless. This example IQOS graph for an application workload with more substantial production I/O shows how migration I/O is reduced when production I/O increases. Note that IQOS can be modified on the fly as the migration progresses. Using this periodic replication, we can update the destination disk in an ongoing manner. For this integration, we can select the option to take snapshots during the migration. The snapshot can be used for pre-cutover testing of the migrated data. Click Add Action to add a pre-snapshot action. For a live database, as in this case, a pre-snapshot action can prepare the database so the snapshot can be taken with full transactional integrity. This command puts the database into a backup mode. Next, click again Add Action and select Take Snapshot and put in the snapshot name. Click Add Action button again to create a post-snapshot action which releases the database from the backup mode. Now the pre-snap, snap, and post-snap actions are configured. Click Create Session to start the migration. Here's the dashboard to let you know how the migration is going. So now the newly created destination disk, DM0, is discovered automatically in NetApp CVO in the Azure Cloud VM, and it's automatically paired with the source Fiber Channel disk. We can observe the parameters of the session, migration progress, and host details. We can see session volumes, source, destination, changes, migration rate, and the remaining data to synchronize. The migration session is created and is started. After the initial sync is complete, every 5 minutes it will perform a resync. We can trigger a resync immediately without waiting. This allows us to verify that the snapshot actions are working. We're now waiting for the synchronization to complete and reach 100%. Monitor this migration session screen. When the status becomes tracking changes, The initial copy is complete, and we can proceed to the next step, which is cMotion. Synchronization is now at 100%, and the session is in the tracking changes stage. In this stage, migration is paused and a dirty map is maintained to track the block level changes. When it's time to cut over to the cloud, the next step is to trigger cMotion, where the workload I/O is swung over to the destination storage. In this mode, there are no more updates to local storage, but a dirty map is used to track block level changes so that if need be, it's possible to revert cMotion back to the source. The ability to cMotion to the cloud and back again makes it possible to perform test cutovers using cMotion. After this, you can observe performance and other capabilities of the new storage tier to confirm everything is working correctly, and if additional adjustments at the destination need to be made offline, it's possible to swing the workload temporarily back to the source while the new storage is being reconfigured, and then you can cMotion to the destination again. We'll trigger cMotion to move the I/Os from on-premises to the NetApp CVO on Azure. Now let's perform the cMotion cutover. Now the source and destination are identical, and the workload is swung over to the destination. The new device on NetApp CVO in Azure is actively being written to, while the source fiber channel disk is now quiet. Observe that the dirty blocks are being tracked and shown here as blue dots as we add database records. After we've used cMotion to move the I/Os to the NetApp CVO on Azure, we are going to complete the final cutover. The action to finalize cutover is to prompt the user to bring the source host application offline and to unmount or bring offline the source disk. Once that's detected, the user is recommended to bring the destination disk online and then to bring the application online for production. This will then complete the migration project. To finalize the cutover, we stop the database at the source on-premises Linux host. This is to make sure the source volume is properly quiesced and is in a consistent state. Then we unmount/data. Let's perform the final cutover. Click Session Actions and select Finalize Cutover. Now the final cutover can start. At this state, the volume is still accessible by redirection to the destination disk. No new changes are accumulating at the source because all the writes are immediately redirected to the destination. It's now time to shut down the source application and bring it up at the destination. Note that this step is immediate and there's no final sync because cMotion already ensured that all updates were redirected to the destination. This allows the Azure Linux VM to mount the migrated disk for production use immediately. We can mount the new device and execute the ls command on the data disk and see that the timestamp of the source. We can see that the time of the database's last access is before the time when the migration was finished. This completes the demonstration of online migration using Cirrus Migrate Cloud end-to-end from deployment to migration to final cutover, all without downtime, and with only a brief transitional outage needed to shut down the source application and immediately start the destination application. What we've just shown is you can move block workloads from any on-premises block source to NetApp ONTAP cloud volumes in the Microsoft Azure cloud while running with no application impact, fully data reduced and encrypted, and with minimal application downtime at final cutover. This patented solution is key for everyone moving to NetApp CVO on Azure from any on-premises fiber channel disk source.